Welcome, intro chemistry students. I created this video to make you aware of the gas chapter resources that are available to you in classroom. I want you to use them to help you answer homework questions and solve homework problems. If you say to me, I can't do it, my first response will be to consult one or more of the resources for help. And if you do that and you still can't do it, then you email me and we'll work on it together. But I need you to actually use the resources that are available to you. Okay, just to walk through them. The first one is your gases notes, as I mentioned. This is what I typically give out to you at the beginning of a chapter for you to take notes in class. So this is what the first page looks like. And also here are the sample problems as part of the notes. So here they are, and they are in the note packet with room to work the problems with me. So ideally, you should be printing the note packet out and using it to take notes. But if you can't, at least work through the sample problems with me on a separate piece of paper. The PowerPoint for the gas chapter has also been posted. It follows the note sheet and contains all the slides that are used in all of the Edpuzzles. I based my Edpuzzles on the PowerPoint slides. So you need to view the Edpuzzle and get a satisfactory score, 70% or better. Once you do that, you don't have to go back and rewatch it to get information. The same information is on the PowerPoint slides. And especially if you are not taking your own notes, use the PowerPoint as a reference to help you answer homework questions and solve problems. A few sample slides. This one gave the information on standard temperature and temperature conversions. This one is the general information about Boyle's law. They're inversely related, which means as one goes up, the other goes down, and the equation that we use to solve Boyle's law problems. These slides walk through one of the examples for Boyle's law, just as I did in the Edpuzzle on Boyle's law. So we start with our equation. However, we cannot plug in two different units of volume. So I converted milliliters to liters so I could use liters. Now you could have also converted liters to milliliters as long as they are both the same. So 711 ml is a unit of volume. 1.89 is atmospheres is a unit of pressure. You need to be able to recognize units of volume, pressure, and temperature. I'll talk about another resource that will help you with that. So pressure 1 times volume 1 equals, I don't know the new pressure, times volume 2. Don't stop here and copy the answer from the bottom of the page. Solve for P2. Divide both sides by 1.44, so P2 equals 1.89 times this divided by that, and you get an answer of 0.933. I need you to show me what P2 is equal to and make sure that the answer you write down here matches the work you've shown. Another resource, pressure conversion, step by step. Homework 4 was measuring gases, where you were supposed to do pressure and temperature conversions. As of sometime today when I checked, only about half of you had submitted this assignment. So I'm going to ask you, if you have not submitted it, to submit it by midnight Tuesday. I have just posted this resource that walks through conversion step by step. I didn't really do that in the Edpuzzle because it's about the 5th time I have taught conversions, but realizing that some of you may be having a problem, I posted this pressure conversions step by step. So here is one of the examples that I posted. If I want to convert kPa to millimeters, no matter what I'm doing, I start by writing down what I gave you. The starting value, 98.5 kPa. Draw your parentheses for your conversion factor. Whatever unit I give you, the starting unit always goes on the bottom of the conversion factor. The one you are trying to find, the new unit, always goes on top. Fill in the numbers for the relationship using Notes, Edpuzzle, or PowerPoint. You can find that 101.325 kPa is equal to 760 mmHg. There's also another resource that I'll talk about that has this information. So 760 millimeters is equivalent to 101.325 kPa. Do the math, round to 3 sigs. You have now converted 98.5 kPa to 739 millimeters of mercury. How to submit gas law problems. Make sure that you are submitting the proper work. Boyle's Law example. You can't just write this down and say V2 equals 258, which appears at the bottom of the page. Several problems with this. First of all, you can't plug in 2 different units and get the right answer. And second of all, you didn't show me what V2 is equal to. So correct submission. Show me the conversion. How did you get them to be the same units? I changed millimeters to atmospheres so I can plug in atmospheres and atmospheres. So I didn't actually show the other form, P times V equals P times V, but from that, you would be able to solve that V2 equals this, 103 times 2.45 divided by 0.98 equals 2.58 liters. So you must show me that that V2 equal step, I know what you put in your calculator, and actually put it in your calculator and make sure that the answer you're writing down, perhaps from the bottom of the page, actually matches the work you've shown. Because if it doesn't, it's going to be returned to resubmit. Also, the same Boyle's Law sample problems that I went through in the Edpuzzle and that appear in the PowerPoint have been posted separately. So it's easy to find, and I will do this for all the other laws that we cover. So, example number 4 of Boyle's Law. Shows you what you need to do, some tips on how to do it correctly. Okay, I'm going to pull up one more resource that I actually forgot to put into this PowerPoint. And it is the gas chapter reference sheet. Has a lot of useful information to help you solve problems in this chapter. So it outlines the volume units you may encounter, milliliters and liters, gives an example of converting milliliters to liters using the fact that 1 liter equals 1,000 ml. Okay. Next is temperature. You may encounter temperatures in either Celsius or Kelvin in this chapter. Anytime you use temperature in this chapter, you must plug it in as Kelvin. So I've given you how to, if you know the Kelvin temperature, how do you figure out, if you know the Celsius temperature, how do you figure out the Kelvin temperature? If you know the Kelvin temperature, how do you figure out the Celsius temperature? Pressure can be expressed in a number of units. The ones we're focusing on are atmospheres, millimeters of mercury, kPa, and pounds per square inch. You may encounter any of these units, and you may be required to change from one unit to another. So I've shown a conversion example using the fact that 760 millimeters is equal to 1 atmosphere. So if you need more help with that, pressure conversion step by step, and you should have completed the homework regarding pressure conversions. Next is a summary of all the gas law equations that we'll be using in this chapter. So when pressure and volume are the units that are changing, we use PV equals PV. Pressure and volumes must be in the same units. I can't plug in atmospheres on one side and millimeters of mercury on the other. So this is the first equation that I've already presented. I will go on to present what's called Charles' law, which relates volume and temperature. This is the equation. And remember, when we plug in temperature, it must be in Kelvin. After that, we'll cover the equation for temperature versus pressure. Looks very similar. V over T equals V over T. P over T equals P over T. And again, temperature must be in Kelvin. The last equation that we'll do is called Dalton's law of partial pressure. It says that the total pressure is equal to the sum of the pressures of the gases that make it up. So when we do get to doing Dalton's law problems, it's important that pressures must be in the same units. So again, I hope this presentation of resources is helpful and that you will use these resources as we go through this chapter.